Hi there, and we are ready for the next round of GraphQL Summit talks. We are going to speak about our GraphQL migration at GitLab so far.
Yeah, probably some of us attended Natalia's talk. So you know she's a part of GitLab, especially the knowledge group and the create stage. In GitLab, the teams are separated by DevOps stages, and create stage is responsible for actually creating things. Everything you create inside the GitLab, starting from the code with web ID, source code entries, or whatever, is handled by this team. And as the knowledge group, well, the main responsibility there is something like to boldly go where no man has gone before. It's obvious that knowledge group was one of the first early adopters of GraphQL in GitLab.
And let me introduce ILLYA. He is working for manage stage, and manage is responsible mainly for gaining visibility and insights about how business is performing. They deal with a lot of stuff starting with A letter, like analytics, authorization, audit, and in case of ILLYA, it's also arguing about different stuff. Manage stage has a lot of legacy code. It's not that modern yet. Probably it's one of the reasons why he loves arguing so much.
Yeah. Before we start the story of GraphQL journey in GitLab, let's say that our technological stack is not mainstream compared to the things you usually hear from the stage. We are not using React. We picked Vue due to its ability to gradually improve our codebase. And we did not pick TypeScript. We have a child trauma. GitLab was written with CoffeeScript long ago. CoffeeScript died, and it's hard to pick something else to replace it. So we are stick with JavaScript, and the story of GraphQL in GitLab started almost 3 years ago when we decided that we definitely need a GraphQL, discussed the plan how we are going to replace the API with GraphQL entry, and to build the rest of the rest on the top of it.
9 months ago, the first issue about refactoring merge request widget was created. And at first glance, you can think like, but this is pretty much trivial. It's just some data and merge button. But GitLab is a complete DevOps application. So this merge request widget can have up to 20 different states, depending on pipelines, user permissions, project settings, and so on. It's really complex both on the front end and backend parts. That's why it was a perfect candidate for refactoring to GraphQL.
10 months later, the merge request widget endpoint was merged into the codebase. Well, this is not because we are so slow developers. You maybe remember the dark times of GraphQL community when people were concerned and discussing about patents permissions from Facebook. But 10 months is definitely a long term for a business. So we had changed the requirements, we had changed our priorities, so the merge request widget actually is still not using GraphQL, at least for now. But the merged endpoint part established the GraphQL infrastructure, which is still used in GitLab. So it was an achievement anyway.
In December 2018, soon after I've joined GitLab, the first GraphQL feature was finally merged to master, and I swear this is just a coincidence, I didn't develop it. And soon after this, the concept of general availability of GraphQL in JavaScript was actually decided, featuring throughput, performance, developer experience, and API maintainability.
Yeah, these three things were our primary targets. And in the January this year, finally, we removed the feature flag from GraphQL, indicating its general availability. But GraphQL is still young and hot in GitLab. We had only 3 or 4 entities in our GraphQL API, like project, group, the most complex one, just 13 mutations, and our frontend is also not heavy user of GraphQL yet. We have approximately 20 queries in our code base. So,
at the moment, I was assigned my first GraphQL related issue. The API was already generally available. So I expected this to be just a walk in the park. Like, it's easy. And what front-end developer does first when we have a GraphQL issue? Of course, I need VS Code plugin because I want to have an auto-completion, I want to have all checks of my queries, and I want to have all the benefits from Apollo plugin. And I need to download schema to feed it to the plugin. And okay, this is easy, it's just introspection query, and I'm getting 500 error on introspection query.
Well, I believe I can explain that. The reason how we are treating the GraphQL from backend perspective in GitLab is, well, it's yet another HTTP endpoint, which is a part of our public API. We have another HTTP endpoints which are not available to the public API, but they are consumed by our front-end part. And the difference is that front-end is performing authorization using cookie and obviously CSRF token. And for other users and consumers of our API, we are expecting to have token authorization. So
actually, CSRF token was the main issue. For some weird reason, our backend engineers expected me to pass CSRF token with introspection query, like we did on cookie-based scenario. Luckily, it was soon, okay, not soon, 3 weeks later, it was fixed, and I could continue with my issue.
Yeah, although this sounds quite anecdotal, it really highlights an important change how we are treating our front end. No more we have a kind of privileged API consumer like front end, but both front end, our other API clients are all using the same endpoint. Everyone is now equal. Of course, depending on type of authentication or authorization, we can assign different limits, but still, the endpoint is the same.
And from the front-end perspective, it makes our work easier, because it's easier to debug cases like my query is not performing.
Well, every time I hear like something will make my life easier, I become concerned. When we are speaking about multiple HTTP endpoints, I have a clear understanding how I can log queries to the specific endpoint, how I can analyze them, and even more, if things go nuts. For example, if HTTP endpoint is abused for denial of service attack across GitLab or for sending spam, we had such cases even like 3 months ago. I'm capable of terminating all queries to this endpoint on our load balancer level. While this is theoretically possible for GraphQL endpoint, we need to support parsing underlying queries on our load balancing part, and this is not a trivial solution still yet to be developed.
And speaking about metrics, there is one every GraphQL developers deal with, even if they never touch backend code. And I'm speaking about query complexity. At GitLab, if you have a GraphQL request, it can fetch data from different data sources. It can use our database, but also it can use GitLY. And GitLY is our front proxy for all Git-related queries.
Consuming any Git-related queries require possible calls to the file system. Sometimes this is very heavy, so each time you are querying the GitLY-related field, our query complexity is multiplied by 2 for this field. But that's not that simple. Even if we are speaking just about database queries, not everything is equal. For example, for issue suggestions, we are building a very complex and heavy query for database, including like. So the problem is that in GitLab implementation, the resolver determines the complexity. So we are passing the arguments to the resolver, and it's up to resolver to identify how complex it thinks the query will be.
With the architecture queries close to components, sometimes we have a scenario when simultaneous queries are run at the moment. And of course, we have an Apollo link batch library to batch all them to the single HTTP request. Or we can exclude some request if it's really heavy and it's triggering query complexity. But I'm highly concerned about the moment when we have an unpredictable environment where user actions define how many queries do we have at the moment, and we have no idea, should we batch all of them? Should we exclude some queries, or maybe we shouldn't just use batching at all?
Well, the real solution, of course, is to share the complexity calculation between front-end and back-end. But since we are delegating the complexity estimation at back-end to the resolvers, it's close to impossible. Another possible solution to this problem is to capture the failure to batch requests on the link level, understand, consuming error code and messages, that this batch failed due to complexity reasons, and to retry all that queries separately without any batching. But this solution is also yet to be developed. Well, I'm happy we are speaking about the concept about GraphQL queries bound to components. Frankly, in GitLab ecosystem, we were using Vuex. Maybe who is not familiar with Vue, it's the Vue alternative for Redux. And well, I do not like Vuex. I do not like Redux for its verbosity. But there is one thing I should admit. It's testable. We can easily test the component bound to Vue store by mocking entire store if I need to test the component. And if I need to test the store logic, I can easily use mutations. Unfortunately, compared to Redux, we do not have pure functions there. We are mutating state, but they are required to be synchronous and have no side effects, so pretty easy to test. And for actions which are actually performing side effects, well, I need to provide some mocks, but it works, and it's easy, and it's understandable. What about Apollo?
With Vue Apollo plugin we're using at GitLab, we are doing pretty much the same. We are replacing the whole Vue Apollo instance. We are asserting that proper queries were run with proper variables, but the thing, and we're mocking the response, but the thing is, Apollo has much more magic underneath than Vuex. And sometimes, some components could expect that cache change should be triggered and components should be changed properly. In React, luckily, they have a React testing library that exposes mocked provider, but unfortunately, we don't have any alternative of mocked provider for Vue so far.
Yeah, well, while this is said, I have even more interesting and a bit rhetorical question for you. How many developers do you think we need to provide a unique ID for GraphQL response? The current answer is, well, just one, but it takes some time. Let me explain what we are speaking about.
Well, let me explain. And this is a really spooky story about unique IDs. This is design management application, and I'm the main front-end developer responsible for this. Design management is all about uploading images and creating discussions on different parts of these images. And one good feature here is we're using Git, so you can have versions of a single design. Imagine your designer provided you with some kind of design, and you upload this to the page. But then, the designer is like in 5 days, oh, it's cropped in the wrong way. You should have a different one. So you're uploading the right cropped image. You check the version, it's good. You open the image to see if it's fine, and hello, Steve.
Well, so why do we have Steve picture for version although it's expected to be Bill? Once again, I have an explanation. The reason is that how we treat your data. When you're uploading the design in GitLab, you are not just doing an upload to some fancy cloud storage. You should own your data. So what actually happens underneath, you are making a commit to your own repository using Git large file storage, GitLFS, and all images connected to your repository are uploaded and stored there. GitLab does not own the data, so you can clone your repository and you will have your issue images. And we are just storing metadata. And since we are using Git for storing images, we obviously have an ID for each image provided by Git. It is guaranteed to be unique. But as you remember, Git calls are very expensive compared to database calls. So, and each issue can include like 10 designs, maybe 100 designs. In that way, the things could very quickly go doomed. So, instead of providing real ID, our backend is handcrafting some kind of fake ID based on metadata.
And it wouldn't be an issue if we had REST API, because in this case, we could provide version number in every single endpoint and also an ID, and the combination of two of them would create a unique identifier. But with the default caching strategy of Apollo client, we have the same IDs here. That's why Apollo treats them as the same.
Well, in order to fix this, at least for front-end side, while we are waiting for backend, we need to jump in and interfere with how Apollo is calculating caches for our type name design. This thing will look a bit nicer with the recent release of Apollo Client 3, but, well, I don't like it at all.
I feel really ashamed now, because guess who is the author of this piece of code? And guess who reviewed it?
Okay.
But yeah, speaking about this, this hack is not even perfect. Even though it looks ugly, it doesn't work 100% of time, because with our strategy of uploading multiple designs, we still can have an invariant error from Apollo because we rely heavily on optimistic responses.
Ah, yeah. We already remembered Steve today, so how does it sound? There is one more thing. So,
this is optimistic response for one of the mutations of design management. And while it looks simple and understandable, it's a real disaster to write all these by hand. While we have Apollo, and the main idea of Apollo is actually to infer these things.
Yeah, the reason why we need to write so much code, because all that are non-nullable fields and they're required. Well, I really love how Apollo approaches to the magic. I really love the code again Apollo provides, but I feel like this is a great opportunity for code generation also. Please give me some tool which will help me to generate this based on the schema which we are already parsing, and to enrich it with the data which is required by my business logic. Currently, this is not possible. Additionally, remember, we are not using TypeScript. We have no way to guarantee right now that this optimistic response is kept in sync with the backend schema. And obviously, this leads to the errors. And well, errors are inevitable in our life and our developers' life. The question is not how you're avoiding them, but how you're handling them.
And another spooky moment, an error handling at GitLab is pretty much minimalistic right now. Usually I just have 500 internal server error and I need to dive deep into development log to understand what's going on here. But we have a bigger issue, because there is a GraphQL spec defining that errors should be handled on the top level.
Yeah, and we have an author of GraphQL Ruby, the game we are using for creating that, and he has his own opinion how we should handle errors. He's insisting that, especially for mutations, you should handle errors as a part of schema, providing additional errors, not the top-level errors. He's making two major points. First, for some reason, really unknown to me at the moment, the GraphQL spec by Facebook explicitly states that there could be only one error for field. So there is no limitations in data structure, just plain array, but for some reason it is. And it's normal for field have multiple, for example, validation errors. That's why it seems weird. And another thing, that when you have error bound to the field and the field is non-nullable, this error is bubbling up till the first nullable field. Well, as JavaScript developer, I don't understand why they do not love bubbling. We do. But as a Ruby developers, it seems they're not so happy about that.
And as a result, at GitLab, we have some kind of lovely mix of errors thrown on the top level and errors as field. And this makes me really unhappy as a front-end developer. Why? Because Apollo client and none of other clients, as long as I know, treats error as field as an actual error. That's why I can't rely on Apollo client error handling.
Yeah, just some a bit more warning from me. The type checking. There is a fantasy land where everything is perfect. And there is a real world of GitLab. Well, and I feel a bit jealous. Why? The TypeScript team did a great job allowing people like us who are not capable of switching to TypeScript to type check our JavaScript files using GSDoc. You are capable to leveraging almost all power of TypeScript type checking without doing actual migration. But there is no tooling available, not in the Apollo ecosystem, neither in entire GraphQL ecosystem, which is capable to generate type definitions with GSDoc. So,
what do we have for a conclusion? First of all, even though it's a spooky story, I can say that GraphQL and Apollo stack allows you to make a gradual migration really smoothly, improving the developer experience, especially on the front-end side, because I'm front-end engineer and I can speak for our back-end engineers, and I hope they won't catch me out of the door to say about their developer experience. Also, it's increasing throughput, and as well, I'm speaking for front-end code. It's really maintainable, easy readable, and it's just easier to work with.
Oh well, it seems I'm not just the guy who is complaining about the things, I'm also the guy who likes to put the asterisks to your guidelines.
Yeah, another A, asterisks.
Yeah. So, well, yes, we have a developer experience. Of course, compared to Rest, it's great, but I'm still jealous it's not as great as React. We still have a room to improve for Vue community. Well, regarding developer performance and throughput, I've spent 3 days researching our metrics and believe, as my team bound to metrics, we are gathering a lot of different performance metrics in GitLab to prove that GraphQL helps us to perform faster. The main question is I could neither confirm it nor deny. Right now, it seems that mathematical statistical methods clearly say that we need more data to evaluate it, and that we are currently just establishing the platform. And of course, we spend some more data for things we've never done before, right? Like writing first resolvers and dealing with weird problems. And well, maintainability, my main concern actually. Well, the maintainability of our GraphQL solution greatly depends on our Oracle skills. Why? As you see, there are still some lines which are not so obvious for us, like error handling, like type checking, and actually there are a lot of more. And if we pick a wrong way, which will not be adopted by community right now, we just will end with the same legacy, just GraphQL flavored. So that's why it is really important for us, and I'm really happy to be here, because discussing the GraphQL future and GraphQL with entire users and entire people who are moving GraphQL forward probably will help me and will help Natalia and will help GitLab to make right choice and to ensure we have a bright future of GraphQL in entire ecosystem and at GitLab especially.
Thank you.
Yeah, thank you.